All right, you guys, I'm going to go over a couple examples from today's notes, and then the rest of the examples you're going to finish on your own, and you're going to check with the pink answer keys that I'm going to post in the back of the classroom. So I highlighted the examples I'm going to go over. Some I didn't highlight because you are expected to finish those on your own. And please behave nicely for the guest in our classroom, your substitute teacher. I would be really disappointed to see or to hear if you guys had a bad report. Okay, so today's learning targets are I can find percent of change and percent error. So let's start with percent of change. The percent of change is a ratio that compares the change to the original amount. If the original quantity is increased, it's called a percent of increase. And if the original quantity is decreased, it's called a percent of decrease. And we find the percent of change by doing difference over original. So what I mean by this is, okay, let's say there's a contestant on The Biggest Loser, which is a game show where you lose weight. You try to be healthier. So let's say their original weight was 340 pounds, and their new weight is 300 pounds. And we're trying to find out the percent change of their weight. You would do the difference of those two weights over the original weight. So what's the difference between these two weights? 40. You're not supposed to be writing this down, by the way. And what's the original weight? 340. And then you would change that into a percent. So you do 40 divided by 340, and you get a long decimal, and then you change it to a percent. It ends up being around 12%. So that means they lost 12% of their weight. So that's what we're learning today. So here we go. Let's look at example 1. In 1970, gasoline was $1.30 per gallon. And in 2010, gasoline was $2.95 per gallon. So this is 1970, and this is 2010. Find the percent change in the cost of gasoline from 1970 to 2010, and then round to the nearest whole percent if necessary. So first, was this a percent increase or decrease? Did the price go up or down? The price went up. So this is a percent increase. So what is the difference between these two costs? So I'm going to find the difference right now. The difference between the two costs is $2.95 minus $1.30. So the difference is $1.65. So the price of gasoline went up $1.65. So write the percent of change formula. You're going to write diff, you can abbreviate, over orig. And then substitute in the percent of change formula and solve. So the difference between the two prices is $1.65. And by original, I mean which price came first in time, which would be 1970's price of $1.30. So now we just have to solve. So on my calculator, I'm going to type in 1.65 divided by 1.30. And I get a really long decimal, and I write the whole thing down except the last digit, because the calculator might have rounded the last digit, so I'm not interested in that one. And then I have to convert my answer, which was a decimal, into a percent. So to convert it into a percent, I need to multiply by 100 or move the decimal over twice. So this is 126.923076. But then I have to remember what it said. It said round to the nearest whole percent if necessary. So now that I made this into a percent, I need to round to the nearest whole number. So this is around 127%. And my answer as a sentence is there was 127%. And you have to say if it was an increase or a decrease. And in this case, there was an increase in the price of gasoline. All right. Okay, on the next page, I'm going to do, oh no. Oh yeah, here we go. I'm going to do example 5 and example 6. So 2, 3, and 4 you're going to do on your own, and 5 and 6 I'm going to do with you right now. So example 5 says, find the percent of change from 125.4 days to 132 days, round to the nearest whole percent if necessary. So I'm going to write down diff over orig. All right, I have to find the difference. So to find the difference between these two things, I subtract them. 132 minus 125.4. 132 minus 125.4. Okay, that's 6.6. So that's the difference. And then I have to put it over the original, whichever one came first. So here it says from 125.4 to 132. So this is the original. So I'm going to write 125.4. In my calculator, I'm going to divide 6.6 divided by 125.4. And I write down all those decimals. So I'll just write down 0.05263157. I don't want to write down the last number because my calculator might have rounded, so that number might be wrong. All right, so here's my answer as a decimal. Move the decimal point over twice to make it a percent. So it's 5.26357%. And then it says round to the nearest whole percent if necessary. So this is a round of 5%. Then you have to say increase or decrease. So was there an increase or decrease? Well, the days increased, so it's around a 5% increase. Okay, now I'm going to do example 6. A teacher's salary is expected to increase by 2% next year. If X represents the current salary, write the expression that represents the expected salary next year. Why would there be a question mark, Miss Wall? That is a sentence. Sorry. I'm going to fix that for next year. You bet your money. Anyway, okay. Oh my gosh, I'm not starting this video over again. So here we go. A teacher's salary is expected to increase 2%. So I know that whatever the salary is, it's going to increase by 2%. So X is the current salary. So here's my current salary. And it's going to increase by 2%. So that means we're going to get 100% of the current salary and 2% extra of the current salary. So that means we're interested in 102% of the current salary, which if I want to make into expression, I have to get rid of this percent sign, so I have to move the decimal over twice. So what I would do is I'd take the current salary and I'd multiply it by 1.02. Now that's because 100% of the current salary is 100% of the current salary. And 2% of that salary is 2% of that salary. And so total, you're getting 102% of that salary. All right, go ahead and turn to the next page. All right, this is the last page I'm going to do with you guys, and we're going to talk about the percent error. Again, I'm not restarting this video. So the percent error means when you make an estimate about something, like let's say there's like a jar of, I don't know, like marbles in the library, and you have to guess how many marbles there are, and your estimate is 120, but actually there's like, let's say 132 marbles. So to find percent error, what you're doing is you're finding out how far off were you between the actual amount and your estimate. So here it's very similar. You do difference over actual. Hold on. So the difference between your estimate and the guess is 12, and then the